Hey, we're continuing with the Chapter 7172 review worksheet number 1. We're continuing with number 6 here. So previously, number 5, we were asked to find the area of this region, which we just did top minus bottom. But now we found the intersection, which we're going to reuse from -5 to 5. But now we're rotating this shaded region around a certain line, and that line is y equals -30. So -30, just to exaggerate, it's going to be somewhere below the curve, below this value here. So we see that there's an obvious gap. So we have to make sure we draw two radius. One radius will extend from the dotted line to the furthest boundary, and then the other will extend from the dotted line to the closer of the two boundaries. Big R is going to be the longer radius, little r is your smaller radius. So big R is top minus bottom. We see the top is sitting on the x squared, so that comes first. X squared minus the bottom of the radius is sitting at the -30, so x squared minus -30. Two negatives becomes positive, so x squared plus 30. Little radius is 2x squared minus 25 minus a -30. So the two negatives cancel out to be positive, combine like terms. We have big radius and little radius. And now we simply put into our formula for Washer method, pi integral from left bound to right bound, big radius quantity squared minus little radius quantity squared. Enter all this in a calculator, leave the pi out of your answer, and whatever the numeric value is, get it down to a fractional value, and then we can add the pi in ourselves. All right, number 8, we're just asked to find the area here. We have the curve y, this linear graph, y equals 3x. That's this slanted line here. We have the curve 7x minus 2x squared. That's the parabola that's opening down. And we're just, we need to find the bounds by setting the two equations equal to each other so that we can have the bounds that we need for our area integral. So we set 3x equal to 7x minus 2x squared to figure out where their intersections are. So we'll bring everything over to one side, factor of 2x out, solve for x, we get 0 and 2. So those are our boundaries, 0 and 2. Okay. And then we do top minus bottom. The top of my length is sitting on the curve, which is the 7x minus 2x squared. And the bottom is sitting on the line, which is the 3x. So it's 7x minus 2x squared. That's my top portion. Minus the bottom, which is the 3x. Clean that up, we get 4x minus x squared. Go through power rule or use your calculator. Reduce it all the way down to 8/3. Again, no pi involved here since there's no rotation going on. There's no circles involved here. We're just adding up infinite numbers of rectangles. So that's all we need here. Okay, number 8. We're taking the same shaded region, but now we're rotating this about a certain axis, rotating it around the line y equals -3. Obviously, there's a gap, so we have to draw two radius, one that extends from the dotted line all the way to the furthest boundary, and one that extends from the dotted line all the way to the closer of the two boundaries. Intersection will stay the same as what we found from number 7. Same shaded region, same boundaries. We just have to figure out our big radius and little radius. So big radius, we have to find the distance between the lengths here. So top is sitting at the 7x minus x squared minus a -3. Little radius, top minus bottom. Top is sitting at the 3x, bottom is sitting at the -3, 3x plus 3. So we have pi, big radius quantity squared minus little radius quantity squared. Enter in the calculator, again without the pi. We get 544/15, and then we add the pi in ourselves. All right, last page of this first review worksheet. Same shaded region from previous, but now we're rotating around the line y equals 7. Y equals 7 is sitting all the way up here. So now we see there's an obvious gap between the axis and the shaded region. We do top minus bottom. Well, first off, we draw the true radius, one that extends from the dotted line to the boundary. Other is going to extend from the dotted line to the closer of the two boundaries. Notice that we don't ever connect the two boundaries of our shaded region. We always have to include the dotted line in our radius, so we always have to extend to that dotted line. So now we do top minus bottom. Top is sitting at the 7, bottom is sitting at the 3x for the big radius, so 7 minus 3x, big top minus bottom. For little radius, top minus bottom, the top is sitting at the 7, the bottom is sitting on the curve, and the curve is the 7x minus 2x squared. Again, careful that you leave a set of parentheses so that we don't forget to distribute the negative through. So now we have 7 minus 7x plus 2x squared being little radius. So we have big radius, quantity squared, minus little radius, quantity squared. From 0 to 2, plug in the calculator, 256 over 15, and then attach the pi ourselves. All right, number 10, we have the shaded region. We have y equals square root of x, that's this curve here. X equals 0, that's this vertical line, that's the y-axis. Y equals negative 1, that's this horizontal line here. And x equals 4, that's this line here. So we have the shaded region, and then we just want to find the area. So the area, we do top minus bottom. So it's the root x minus the line below, negative 1. And then our bounds, we can tell because we have just nice horizontal lines, nice vertical lines on either side of the boundary. So we can tell that's 0, and this is going to be 4. So from 0 to 4. Enter in our calculator, or we can work this out by hand using power rule. Either way, we get 28 over 3. All right, number 11, same shaded region. We're just rotating about the line. Now the line is y equals negative 1. Notice here that there is no gap between the axis of revolution and the shaded region. It's right up against the flat surface of the shaded region, so all we need is one radius, which means we only have to do this method. So we extend from the dotted line to the furthest boundary of the shaded region, and then we do top minus bottom. Top is sitting at the root x, bottom is sitting at the negative 1, so we have root x plus 1. This method is pi big radius squared with our left and right bounds. Enter in our calculator, or we can work this out by hand, expand, and do power rule. Either way, we get 68 over 3, and then we can attach the pi ourselves.